Alright guys, and on to number 12. Number 12 is talking about a function that is x squared, and then it talks about some transformations that happen to it. So the first transformation is that it is transformed or translated 5 units to the right. Okay, so 5 units to the right is going to take it from the origin. Sorry, pen malfunction. So from the origin of right here, 5 units over to right here. Okay, then the second transformation that happens is that it's vertically stretched by 2. So remember when we talked about quadratics, we talked about a pattern, and that pattern was the 1, 3, 5 pattern. Okay, so normally our quadratic would go up 1 over 1, up 3 over 1, up 5 over 1, and then it would repeat on the other side. And then it would look like this. Okay, but since this one has a vertical stretch by 2, we're actually going to multiply this pattern by 2. So instead of being 1, we're going to say 1 times 2, which is 2. Instead of being 3, we're going to say 3 times 2, which is 6. And instead of being 5, we're going to say 5 times 2, which is 10. So our pattern is now going to be 2, 6, 10. Okay? And then our last transformation is going to be reflected across the x-axis. And all that reflection means is that it's going to be turned upside down. So instead of going up 2 over 1, we're now going to go down 2 over 1. So down 2 over 1. And then next comes 6. So down 6 over 1. And then I can't go down 10, so that's as much as I can do. And then I also have to reflect it to the other side and make a U shape since it is a quadratic. So I have to check off and make sure that I did all 3 transformations. So it translated right 5 units, so that one's checked. Vertically stretched by 2, so I went from 135 to 2, 6, 10. Sorry, I'm outside. So that one is done as well. And then reflected across the x-axis, so it should be upside down. So yes, all 3 of those are checked. I'm going to try to zoom in because I noticed yesterday that it was a little bit zoomed out. All right, number 13. On number 13, it talks about a normal distribution, and we actually did this with your very first test. And I had intentions of doing it with your other test, but we didn't ever actually get to it on the original. So we talked about with the first test, Unit 4 test, the bell curve. Okay, and it says that your mean is 71. Okay, so that's going to be the one that goes in the middle. And your standard deviation is 6%. So that means that the next part is going to be 6 from 71. So 71 minus 6 is 68. No, I'm sorry. I'm losing my mind. 71 minus 6 is 65. And then 71 plus 6 is 77. So now here's the tricky part. We did talk about this. This is actually 68% of the values. Okay? And the question is, how many students would you expect to have scored between 65 and 77? So this is 68% of your students. But if we have 150 students, then what is 68% of this 150? So we're going to multiply 68% times 150 to get that. So anytime we have a percent, we have to change that to a decimal. So that's going to be 0.68 times 150, which is actually 102. Okay, so that is going to be answer choice C. All right, number 14. Number 14 says to create a graph to show the intersection, so that's a big important part, of y equals x minus 5 squared plus 1 and y equals x minus 2. And it wants you to make sure that you label it and have the appropriate increments. Okay, so first let's talk about x minus 2. I know that my y-intercept is negative 2. Right, so I'm at least going to have to go 2 units underneath the x-axis to get what I need to have on this graph. Okay, my slope is 1, and that's pretty much all I need to know for this line. Okay, then I have y equals x minus 5 squared plus 1. From this, I could tell my vertex. And your vertex is always going to be the opposite of what's inside the parentheses. So that's going to be a 5 and a 1. Okay, so both of those are positive numbers. So that's going to be in your first quadrant. So that's a good sign. And A, which is in front of the very first thing you should see, is a positive. So that means it's going to go up like this. So everything's going to be in the first quadrant, which is a good sign as well. Okay, so the only thing that I need in this graph is going to be over here, and that the y-intercept is going to be negative 2. So really on this graph, all I need is for the y-axis to have 2 units below for that y-intercept to be negative 2. And just for safekeeping, we'll go 2 units this way too. Your graph can be different. It doesn't have to be the exact same, but just to kind of show you all. Okay, and then it wants to make sure that you label. So this is x, this is y. Okay, and we will do the purple one first. So x minus 2, so my y-intercept is negative 2. So 1, 2. My slope is 1, so I'm just going to go up 1 over 1 from there. Okay, the second one is my vertex is 5, 1, so I'm going to go over 5, up 1. And remember, we talked about on the last problem the 1, 3, 5 pattern. Since A is 1 right here, this is a 1, then it keeps that 1, 3, 5 pattern. If it was a number other than 1, then we would multiply it by whatever that number is. So from this point, I go up 1 over 1, up 3 over 1, up 1, 2, 3, 4, 5 over 1. And then I do the exact same thing from this point going to the left. Up 1 over 1, up 3 over 1, up 1, 2, 3, 4, 5 over 1. And then you can actually keep going on this one. After 5, it's just your odd numbers. 7, 9, 11, and so on and so forth. So we can actually go 7, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. So this graph we could fit a lot in. Alright, number 15 is talking about logarithms again. So it says select all that apply. So I have 4x equals 12. Okay, so I can actually change this to log. Remember your base, which is 4, stays the base. The number that it equals comes next, and then your exponent is what's last. So this is actually option E. Okay, then we can actually use our change of base formula, which you learned in your second video before spring break, to be log 12, the big number goes on top, over log 4, which is option B. Okay, and then you see these crazy numbers with LN, and we haven't actually talked about these yet. You know that it's not option A, and you know it's not option F, because we've already done ones with those in it. But you see these ones with LN instead of log, okay? And there's actually a button on your calculator with LN, okay? So I know that some of you don't have graphing calculators at home, and in the announcement on Canvas, I actually put that you can go to Desmos. So if you type in Desmos, this is kind of what you see, and it's a great alternative to graphing calculators, and it's just online and it's free, and so this is kind of what you see. So we're going to actually type in log of 12, maybe he's going to type in log of 12 divided by log of 4. Okay, and we see that it's 1.79. So then, let's type in ln instead of log and see what it says. Ln of, let's see, option choice C was 4 divided by ln of 12. So that's not the same thing, okay? Now, let's see about ln of 12 divided by ln of 4. That is the same thing. So I know that log of 12 divided by log of 4 is the same thing as ln of 12 divided by ln of 4. So option choice D is actually the same as well. So my answers are B, D, and E. Alright, then we have number 16. Number 16 is a 4-term polynomial. Okay, and we know for 4 terms that we are going to use grouping. So when we group this, we have our greatest common factor of the first one, which is x squared, and we're left with x plus 5. We have our greatest common factor of the second one, which is 2, and we're left with x minus 4. Now, if you notice something here, what we have inside the parentheses is supposed to match. We're supposed to have the same thing. And on this one, we have x plus 5 and x minus 4. That's not the same thing. Okay, so grouping doesn't work here. Okay, so our second option is to go back to Desmos, to go back to our calculator, and we're actually going to type this in, and we're going to see what happens on this graph. Okay, so we've got x to the third plus 5x squared plus 2x minus 8. Alright, and here is your graph. Let me zoom it out. Okay, and the question is asking what the factors are. So we can tell the factors by where it crosses the axis at. Okay, so you see oh my goodness. So you see that it crosses at -4. Okay, so that means that our factor is actually going to be the opposite of that. So if it crosses at -4, again, if my pen decides to work, -4, then my factor is going to be x plus 4. It's going to be opposite. Okay, so there we go. Going back here, if it's at -2, then my factor is going to be x plus 2. So that's E. Then if it crosses again at +1, because that's 2n, so that's a 1, then that's going to be opposite. So since it's a +1, it's going to be -1 there. So that's option choice C.